This is a text-to-speech presentation. The original presentation was in Hungarian language. The text-to-speech software was used from mtranslator.com.
I am leading the IT Quality Assurance Department at Raiffeisen, and I would like to present to you, through a few slides. What do I see with the eyes of quality assurance? What do we see from the application and functions of TRMT? First, I show the development process that George Tokovich was referring to, and through that, I show how the three of us split the work between us, and what functions and possibilities TRMT provides approximately, at which point of this process, or what kind of possibilities we see in TRMT, issue handling, development, scripted build. I would like to go through these. This is our main development process in a much compressed form. We are writing specifications, planning the architecture, prepare the module view of the software architecture document, and when the future structure of our code comes together logically, we perform the logical and physical design, develop a little bit, and do the development testing. All this in a development environment that has the main characteristic that it is not that integrated yet. After this we work in the future FIT. I say this for the sake of our own colleagues. Some of the things I am telling here are just plans, or are in progress. They would realize that establishing the FIT is still in progress. There is a preliminary environment that is not as much integrated as the future one. Later developers' integration test will be performed here, and when we already consider the application to be appropriate, then it can be transferred through a checkpoint to the integrated environment that serves for the support of functional and user testing. We will also perform here the non-functional tests, I mean by this especially the performance tests, and when we decide that the software has appropriate quality, then it can be transferred to the production environment. I can show here the work split between the three of us, our sandboxes. The sandbox of George Tokovich ranges from the physical planning, architecture planning up to the end of FIT, or the beginning of INT. Then it's our turn when we supervise especially the support and coordination of testing, and the preparation of Go Live. Then it's Gaber's turn, ITS, live operations, and deployment to the live environment. Obviously we reach through these because we are always there at the beginning, and at the end as well, but this is the main responsibility, and I used to say that we are there in the middle, sometimes as a bridge, sometimes as a boxing bag, depending on the situation. These are the three operations. George Tokovich talked roughly about the beginning, I talk about the middle a little bit now, and Gaber will talk about the end. George has already mentioned that everything we have established during the years is there now, so we have to tie together developments that are pretty much interlinked, developed on different platforms, and having an individual life cycle. Say if we look at a development task, it is typical that one part is AS400, another part is Lotus, and the third part is Java development, and TRMT can provide us great help primarily in the Java area, but even this is far ahead compared to the situation of not having it. At the very beginning of the process, at the planning, I look at things with the eyes of quality assurance. When we created our architecture plan, the application under preparation has a logical structure, then it is possible to create the components and units in TRMT. Here, we define the release process, in which this will be implemented. We capture, or take over the requirements, but I will talk about this soon, and we decide in which process the individual requirements will be implemented. This is the support that TRMT provides as a basis. This is a very important input for us, and Rosh talked about these. I will just name them. If we define these components here, then these modules are important inputs for us, since when we create the structure in our test support tool, for us this is Quality Center, or Test Director with its former name, and we define test cases for it. Then we define them exactly to these components. we test the services, interfaces, database elements that appear in Test Director. There is another type of communication here. I will talk about it on the next slide, but the other important thread besides testing is the handling of installations, installation tasks. We call them by nice trendy names, change processes, and configuration handling elements. Actually, it is about the case that when we create a new release, a new deployment task in TRMT, then we have to transmit these to the current environments through the change processes while we modify the elements stored in our configuration management database, or we even create them, and in reality we work on the same elements, we modify the same database, the same service, the same interface, the same application. Our entire framework where these tools are operating is called Program with the old name, now its married name is Services Manager. This is not entirely true here because the WSSR mentioned by Androsh and George can be actually considered as a CMDB from the services point of view, and this is topped with the tool that provides human workflow support for this technical process, and the help is not only that the code itself gets from TRMT into the environment, but we can plan the entire process, we can schedule it, allocate it to responsible persons, and we can protest if we don't want to deploy it yet to the given environment. And then, as I promised, I talk in a little bit more detail about the handling of requirements and issues. These issues, or requirements, can be some new development requirement, but usually, I am much more interested in it, if it is some bug, or a bug fix. These requirements and bugs can get into TRMT directly, we strum it in nicely using its own interface, but it is much more exciting if it can get in through some external system. As Androsh mentioned, it is now integrated by default with Bugzilla, but our standard tool is Test Director, or Quality Center, so we are piloting this functionality, and we plan this integration. All this is about the following: say, when a bug gets into the system, and we have decided, say by setting a status, that it has to be fixed, then this info, respectively the info in which project it is affected, can get into TRMT. Here the components and units that are affected are connected to it, that is the ones that need to be touched for the bug to be fixed. It is nicely determined when it will be fixed, translated, in which release it will be implemented. This release info is determined, and can nicely get back into the tool. When I am planning the testing, then I know on what bug fixes I can count when, and in which release, and which of them needs to be retested. Then the developer, when she implemented it, and did the necessary modifications, she makes a declaration: I am ready, the fix is ready in my little component, and you will be able to generate a release out of it when each affectedness marked here will be ready in each individual element of the given release. Then it gets back nicely into the bug tracking or issue tracking system with a status change, that this bug is ready, it has been fixed. This will be very important for me. I can plan nicely which one will be fixed when, and when coordinating the testing I will be able to say, dear user testers or dear functional testers, these are the fixed bugs, and they can be tested. This was the planning, then comes the development. For a very long time my attitude towards TRMT usage was that my role is to enforce that developers and the colleagues from ITS use it, but I will look at it from a distance. Then it turned out that we'll not look at it from a far distance. One of the important topics we had to fight with very much was to enforce developer tests, unit tests. We don't feel like believing it just by saying that they have done it. Therefore we set all kinds of documentation expectations, so that these unit tests are there in the version handling together with the code, and they can be reproduced and executed. Another ray of hope or possibility here is that when handing over code, a declaration needs to be made what verifications have been executed, so for example, that it has been tested and documented. This is a little more sophisticated documentation method than expecting Word documents from them. The other topic that George also mentioned is that TRMT explores the dependencies. Respectively, we can add all kinds of compatibility conditions to it. At debugging, especially in the service period when a bug gets into a service, then we need to yank out which are the clients exactly where we need to pay attention very quickly because there might be problems. It can provide great help for this. It also helps when we plan a go live, and say we stand there at a Friday evening install when we should deploy 52 elements. If we can take some of them forward because we know it will not disturb anybody, they are completely independent from the others, then this is a help. And it also helps if I look into an environment, and I know, for example, in an actual test environment what is already there, and what is still needed, what has to be still deployed there in order to make that application or that project actually functioning and compatible. This will be Gabri's area, the scripted deploy and build. I have talked about environments on the first slide, that we have development and integrated developer and user test environment. These environments appear as entities in TRMT, and all kinds of things, servers, and parameters can be set for them. It is exciting, for example, that I can define through this even according to which work process the deployment should be performed, so I can specify that the developer is also entitled to deploy into the FIT, but for example into the INT only the colleagues from ITS should be entitled, and if George's team doesn't do it correctly, then we take away this permission from them swish smack, and starting from that time they are not entitled anymore. We do all this the scripted deploy and build to decrease the risk of installations, because the steps described in the long install sheets executed manually can be pretty dangerous. It is also important for the dear auditors to demonstrate that the code that has been deployed was exactly the one that we have tested. This way that it can deploy only a closed release there they usually believe it, otherwise they usually don't. It is very important, and George also talked about this, that the script we use for deployment is in fact a development, a code, and this code needs the same kind of quality assurance, it needs to be tested the same way, and it needs to be achieved that approximately the same thing runs in the individual environments. That's why it is important to be able to check these scripts using this approval process. We check whether it complies with our standards. Then we quasi-test it when executing it in an actual environment. So for example, if we deploy into FIT using these scripts, then we have already tested those scripts, and we can be more relaxed. This is a very important rule. It's a wasted effort to write scripts if we correct the errors later manually, and we don't make the effort to correct the original script, then we do more harm than good. So by obeying these rules the possibilities for error will certainly decrease.